Hi, welcome to High Growth with HTDC. I'm your host, Cindy Matsuki. And HTDC is the state's tech evangelist, so we support all things tech, entrepreneurship, innovation, and manufacturing. And there's so many awesome things going on in Hawaii, and this is the place where we like to talk about them and share them with you. And one of the great things is Makai Ocean Engineering. And my guest today is Duke Hartman, Vice President of Business Development at Makai Ocean Engineering. Thanks for being here.
Thanks, Cindy. Happy to be here.
So Makai Ocean Engineering was founded in 1973, making it 42 years old this year.
Yep.
That's amazing. That's great. What is Makai Ocean Engineering, and how has the company survived for so long?
Well,
what's the secret?
Yeah, sure. To give an analogy, if you know NASA. So if you think of NASA and you boiled it down to 30 people, and then you told them to work on problems in the ocean, that's Makai. It's the guys who work on the really difficult stuff in the ocean, really kind of hairy problems that no one else wants to deal with. So like top in their
field, they know what.
Yeah, and so in a few areas, Makai is the top in their field, and so it's a really dynamic, really interesting company with a broad range of kind of technology and expertise for such a small company. And so that's how they survive. They find technical niches in the ocean and just exploit them and create commercial products out of it.
Has it evolved, or has it always been like that from the start?
Oh, it's constantly evolving. Even right now, we're kind of changing tack, because when you're small, you have to be nimble. You can't be, if you're a Lockheed or a Boeing, you can rely on maybe government contracts, but if you're a small guy, you got to kind of fight to survive. And if the gas prices go down, for example, and technology changes in some area, you got to shift,
go to where they're
and get innovative, basically. Innovate or die. It's really, that's how it is.
Holy cow. And you're in the perfect place, I guess, for ocean engineering.
Yeah, we do a lot of defense-related work as well. So in some cases, it might be better to be in DC or something like that, where a lot of the clients are, but it really is an ideal place to be in Hawaii for testing, and this is the tip of the spear out here, where there's a lot of Navy work. So it is, and really, it's interesting because the founders were, one of the founders, Joe Van Ryzen, was a grad from Carnegie Mellon, and he came out here in, I think, 72 to work for another company. That company went belly up, and he said, "Hey, I've got my wife, my child out here. I love Hawaii. I don't want to go back to the mainland. I got to make it work."
That's amazing.
And we found that all of our engineers here are world-class talent, and they could be anywhere and be doing a lot of different things, but they want to be in Hawaii because it's Hawaii. I mean,
that's awesome.
It's an ideal place to live and work and play.
Great. Do you have a lot of people from all over the place, or do you have a lot of local people?
Yeah, no. We've got a bunch of international workers. So we got
that's great.
One from India, two from Japan, one from China. Recently left the company, but one from England. And then we've got remote workers across the country as well. So no offices in other countries, but almost 70% of our work is international.
Wow.
So mostly Asia Pacific and even Europe. We've got a lot of clients in the North Sea.
So what is your main product? Like what are these customers buying from Makai?
Well, in a big general sense, it's engineering services. So it's someone who has a problem in the ocean and says, "Hey, look, the guys in our industry haven't been able to figure this out. We know you're kind of a creative, kind of think out of the box. Here's the problem. Come up with a solution." And so we've got oil and gas clients who, pipelines and risers and cables. They need help there. One of our main businesses is the subsea cables. So the internet, about 98% of the world's international telecommunication traffic goes through submarine fiber optic cables. So these little cables that are laying on the seafloor. If you look at a map, the world looks like a spaghetti, bowl just covered in submarine cables. And Makai, early on, when people were really starting to lay cables in the dot-com boom, a bunch of people started doing it, and Makai came in early and helped those guys install their cables on the seafloor. Developed the software actually to help the cable ship navigate and install the cable on the seafloor. Kind of quickly, safely, and just saving cost basically by reducing the time at sea and knowing accurately where the cable is on the seafloor.
Wow. So Makai develops their own technology, like
Absolutely.
in-house.
Yeah, almost, we do use commercial software, but a lot of the software we use are developed in-house. So probably half of our staff is software engineers.
And do you build hardware as well?
Yeah, we're getting more into it. Absolutely. In the past, 5 or 6 years, we've got an OTEC facility over in the Big Island, so that's all hardware. And more recently, we've got an underwater vehicle program. Yeah, so an autonomous underwater vehicle program, and that's all hardware as well. Some software, but
that's cool.
Mostly hardware.
Maybe for those of us who don't know totally what OTEC is, can you kind of explain?
Yeah, sure. So I like to put it this way. So everyone knows about renewables, right? So there's wind and there's solar, and those are Makai's a big advocate of those technologies as well, working a little bit in both of those. But the kind of slight problem with wind and PV is that, okay, when it's sunny, you've got solar energy. When it's windy, you've got wind energy. But when it's not, both of those things, what are you going to do? So both of those technologies are great, but they also need energy storage if they're going to be stable, basically. So it's what they call intermittent, so it goes up and down. And so the beauty about OTEC, so a question for you, what's the world's largest battery? What's the world's largest energy storage system?
My guess is the ocean.
I gave you a little bit of a hint there, but correct. So OTEC is really solar energy. So the surface of the ocean is collecting solar energy all day long in the tropics. And so it's thermal energy, so it's heating up the surface of the ocean and storing it there, which you can extract it at any time you like. And so for that reason, it's called base load or firm power. So it's continuous 24 hours a day, 7 days a week, 52 weeks a year, all the time. And so you don't need that energy storage component. You don't need a big battery rack to, store the energy when you've got it and then draw it back out when you don't.
Okay.
And so that is the top level reason why people are really interested in OTEC, is because it's firm, it's renewable, so there's zero emissions, but it's also firm. It's base load 24 hours a day. And then in addition, it's a huge resource. It's not just some kind of like little thing that applies in a few areas. All across the tropics, in the entire, not in the entire world, but a lot of places around the tropics, OTEC works.
So how do you extract that energy?
Right, so that is the tough part. So I like to tell kids, one of the really nice parts of my job is we get to go and talk with middle school and high school students about STEM education.
That's awesome.
And shout out to Kathy Kawaguchi with the Chaminade program. They do a really good job. ONR sponsors kind of a STEM education. And when we go there and talk to the students, I like to talk about thermal energy. And, thermal, it kind of like escapes these kids' grasp because it's like, okay, thermal, what is that? Thermometer. Okay, temperature. I get it, temperature. All right, that makes sense. But I don't think they understand that 90% of the world's power is generated through thermal power plants. So oil-fired plants, coal-fired plants, even nuclear, they're using a cycle that uses thermal energy. And for a thermal power plant, you just need two things. You need hot source, so something that provides heat, and something that provides a cold source. Okay? And how hot and how cold they are dictate the efficiency of the system, so how much power you can generate.
Okay.
So the ocean already has those two things, a hot source and a cold source, in
I
it
think we might have a
already.
picture of something like that.
Yeah, and there might be a picture. Okay.
Is that OTEC?
That picture right now is showing?
Yes.
Okay, so that is a little diagram of the OTEC system. And it looks a little bit complicated, but
It does look complicated.
yeah, so if we just want to walk through it, the only inputs to the system here are warm seawater
Okay.
and cold seawater.
Okay.
So that orange pipe you see on the left there, that's
Uh-huh.
warm seawater coming in.
Okay.
So
From the
what that-
surface.
From the surface.
Uh-huh.
And so what that seawater does is it goes through what they call the heat exchanger. Don't get bogged down by the name. It's really just a metal plate that separates this warm seawater from a working fluid. And that working fluid is something that boils at a really low temperature. And so as an example, if you cut back to, I've got a little prop here. So in this little vial, we've got a purple working fluid. We'll call it a working fluid, okay? And what this does, and I like to use this with the students too, because it demonstrates the actual what's happening. So this fluid here, if you put your hand on it, the heat from your hand is powerful enough, and my hands are pretty cold right now, but if you make a little friction, warm them up, the heat from your hand is powerful enough to drive that liquid from the bottom of the vial to the top. And I don't know if you can see it very well, but in a moment, it's going to begin to do what looks like boiling. So you see
very
there,
nice.
it's starting to bubble.
So this is like the heat exchanger.
Right, and so this is a heat exchanger. You're taking, all that means is exchanging heat, right? So you're taking heat from your hand and putting it into this
The liquid.
system here. Yeah, maybe do you have warmer hands?
Okay.
Yeah, there you go. And so if you put a tiny turbine in there, the vapor that's going past this vial right here would be able to generate power.
Ah, cool.
Right. And so that's what the warm seawater does to the ammonia. So maybe if we cut back to that diagram, you can see, okay, the warm seawater comes in, it heats the working fluid just like you saw in this little vial, and then that turns it into high pressure working fluid. That high pressure vapor goes into the turbine. You can see the turbine at the top right there, and basically all the turbine is, it's like a wind turbine. Think of a wind turbine, and it's just a wind turbine that has really high pressure vapor that's blowing past it and spinning it in a rotational manner. And so that's what generates the power. And then really what's driving the system is the cold side. So you're also bringing up cold seawater, brings that vapor to a low pressure.
I see. So it's actually pulling it through.
Right, it's pulling it through. And then it condenses the vapor back to a liquid and then pumps it back around. And so the working fluid doesn't go anywhere. It's continuously, going in a circle. That's why they call it closed cycle, because the working fluid just continues to move around, and you're basically extracting a little bit of heat energy from the warm surface water and then discharging a little bit back to the cold seawater. And so in net, and that's enough to generate power on its own, and supply the power for the pumps, because you do have to pump the seawater in, and so it does more than supply the power for the pumps. And it's 100% renewable, it generates no emissions, and all you're doing in a net effect is cooling down the ocean a tiny bit.
So
you're literally extracting heat.
So does Makai build systems like this?
Yeah, absolutely.
I've read about the AC with OTEC.
Right.
Is that something?
Yeah, and so there's kind of two different technologies that are that Makai and others are looking into, and they can be divided into like electricity generation, so generating power, and then generating cooling. So just using the cold water for cooling. And that's a simpler system. So OTEC is the one we just talked about. That's
with
for
the
generating.
warm and the cold.
That's literally just generating electricity. So nothing to do with AC.
Okay.
You could use the cold water for AC, but in most of these plants, they're probably going to be offshore. And so the cooling aspect, it's not near a city. But
Oh, I see.
so OTEC really is focused on power generation, electricity.
Okay.
But seawater air conditioning, what you just mentioned, is a simpler kind of spin-off, sister technology of OTEC.
Huh.
And it's really simple. All you're doing is laying a big pipe way deep down in the ocean, pulling up this cold water that's near freezing.
Wow.
It's can be 45, 44 degrees Fahrenheit, so pretty dang cold.
Yeah,
And then you just
that is cold.
pump the water and basically extract the cold from the seawater, put it into fresh water, pump that fresh water in a building in a coil, and then blow air across the coil, and you've got cold air.
Huh.
Really pretty simple, low tech.
Yeah. And then you just put the seawater back.
Yeah, and so you've warmed up the seawater a tiny amount, but you just put the seawater back. And AC systems in general, they're heating up the atmosphere. So it's not like that's anything new, that you're warming up the environment. But it's actually kind of better for tropical areas because, in downtown here and Waikiki and other like Guam, tropical areas, conventional AC really heats up the surrounding area because they're just rejecting the heat into the air.
I see.
And so this is rejecting the heat into the seawater, putting the seawater
So
back
you
down.
don't actually heat up the rest of the surrounding area.
Right.
Yeah, interesting. I never thought about that.
And so it works in really big kind of developments. So you're probably aware of the project in Honolulu, in downtown Honolulu, Seawater Air Conditioning. So that's a separate company developing SWAC in Hawaii, and Makai is supporting them. So we're really excited about that project.
Yeah, is that what it's called, SWAC?
SWAC, yeah, that's the short acronym for Seawater Air Conditioning. Yeah.
That's
So,
great.
and that's actually more commercial right now than OTEC is, because there are already systems in operation around the world. OTEC, by most standards, is still in the R&D phase. We've yet to see a really commercial OTEC power plant.
Is it because of the efficiencies, or is it the technology's not
Right.
quite there yet, or?
And so that's a whole topic, and no, it's good though, and I think we can maybe dispel a little bit of myths about OTEC.
Okay.
Because if you've been around in Hawaii a long time, you've probably heard of OTEC even back in the 70s.
Wow.
They were doing OTEC research over
Okay.
in Kona. The Natural Energy
yeah.
Lab, that was actually founded for OTEC research. A lot
Wow.
of people don't know that. But
Okay.
so people say, hey, OTEC's had its chance, it's had its heyday, it never went anywhere, it's dead. Well, it's not true. The one kind of hurdle that OTEC's been dealing with this whole time is that it works on a really big scale. So an OTEC plant that could supply power for, say, 100,000 homes, so 100 megawatts, for example, roughly speaking, that would be a commercial, viable OTEC plant. Okay, so it's a big system, And at that scale, we think we could provide power at about 20 cents a kilowatt hour, which is quite a bit less than we're paying right now as ratepayers. We're paying about 35 plus. So that's where OTEC, that's the pot of gold at the end of the rainbow.
I see.
But to get there, we've got to create a plant that's, looks, tastes, and smells like the big OTEC plant, but is in operation for several years. But the problem with that plant is it's expensive and it's not the best investment by itself. So it's still can close to break even on a small scale, but it's not going to be, you're not going to have
Making
Wall
money.
Street knocking down your door just to build the pilot plant. But in order to get to the moneymaker, you've got to get through this pilot plant. So that's what we've been struggling with for a while now. And it just involves getting together a group of both investors. I think you need private sector and you need government who are forward thinking enough to say, look, this is not only a good investment, but it's what we need to do in terms of our renewable future, and say, look, we're going to bite the bullet, build this pilot plant. That's going to allow us to get to the bigger commercial system.
Huh.
So we're hopeful,
out there.
and there's a lot of really kind of interesting international stuff that's been going on with respect to OTEC. So
Good, very good. So
we're excited.
So hopefully it'll be coming soon.
Yeah, so China is interested. Japan has plans for an OTEC plant, and we're working with them. In Malaysia just recently contacted us about an OTEC plant. So there's a lot of kind of interesting
that's
stuff
good,
going
and
on.
potential. Good. We're going to take a quick break.
Okay.
We'll be right back.
Okay.
My guest today is Duke Hartman, VP of Business Development at Makai Ocean Engineering. This is High Growth with HTDC. I'm your host, Cindy Matsuki, and we're on ThinkTech Hawaii.
Aloha, I'm Hunter Hevelin, host of Sustainable Hawaii here at ThinkTech Hawaii. You can tune in every week on Thursday at 2 p.m. to see interviews with sustainability professionals from around the state and even further abroad, learning about activities with water management, food security, waste management, and a whole host of other fascinating opportunities to get engaged with making a greener island. So if you're interested in making the transition from consuming individuals to communities of producers, check us out every Thursday. Aloha.
Okay, I'm Jay Fidel, that's Ray Starling. We co-host a show called Hawaii, the State of Clean Energy, every Wednesday, 4 to 5 p.m. It's really interesting. You know, Ray has a way of unzipping these guys. He asks them these questions and all this stuff tumbles out, and we find out stuff we would never know about without Ray's questions. Thank you, Ray.
You're welcome, Jay. I'm very pleased to be your Ed McMahon every Wednesday at 4 o'clock here on the internet. So you can join us and see what's happening in the energy world, and there is a lot going on. So join us every Wednesday at 4 o'clock.
Yeah, come around, be energized right here on ThinkTech. Aloha.
Hi, welcome back. This is High Growth with HTDC. I'm your host, Cindy Matsuki, and I wanted to let you know what's going on this month because there's a lot going on. January 28th, the Hawaii State Library will be hosting a patent and trademark searching workshop. Find out what you need to do to protect your IP and hear lessons learned from other business owners. This is a full-day workshop, and it's free and will be held at the Aiea Public Library, featuring Neil Mason and Tom Turner of the U.S. Patent and Trademark Office, as well as HTDC's very own Len Higashi, Joe Burns from SBDC, and Jana Uehara from the Business Action Center. Registration is required, so please call 586-3477 by January 23rd to ensure your spot at this cool workshop. Also on January 28th, after the patent workshop, head on over to Wetware Wednesday at the courtyard in front of Manoa Gardens on UH Manoa's campus. UH's Department of Information and Computer Sciences is sponsoring the event, and we'll learn from ICS Professor Dr. Scott Robertson how social media is affecting our decision-making, which should be interesting. In February, which will be coming up quick, AT&T is hosting a mobile hackathon in February from the 13th to the 14th at Iolani School's Sullivan Center. They will be awarding $6,000 worth of prizes to the winners. And Wetware Wednesday, reminder, is a good place to start building your team. So register for the hackathon today. For businesses and entrepreneurs who need some quick legal advice, every other Wednesday, HTDC offers free legal guidance in partnership with the Business Law Corps. You can sign up for a 30-minute appointment at the Manoa Innovation Center. Please visit htdc.org/legal to sign up. I want to let our entrepreneur community know that we have office space available at the Manoa Innovation Center. We offer a collaborative community, co-work spaces, office services, and great programs for starting businesses. For more information, please visit our site at htdc.org. Lastly, calling all SBIR Phase 1 winners. HTDC offers the state's matching fund for up to 50% of your Phase 1 award. So if that's you and you've recently won a Phase 1, please contact us at sbir@htdc.org. All right, back to our guest. Our guest today is Duke Hartman, VP of Business Development at Makai Ocean Engineering. And I was just wondering, like, you have all these international clients and interest. How do you find these people? How do they find you?
It's kind of a combination of marketing and going to conferences and just because we're kind of really specialized in each area. So you could say we're specialized in ocean energy, in marine pipelines and submarine cables. So those kind of
So you
three
just hit those
technical areas. And so
industries.
we kind of know the magazines where we should publish technical articles or editorials,
That's good.
do ads, go to conferences. And so it's, we're not a huge company, we're 30 people, we don't have a giant marketing budget, so we need to be kind of,
Focused.
guerrilla marketing about it.
That's great.
And
That's good.
have a really kind of targeted marketing.
Sounds like you guys
points
are
for
doing a
each
good
area.
job at it. We have some pictures to kind of show some of the different projects that Makai is working on. Maybe we can bring some of those up and talk about what Makai does. Ooh, what is
Okay. Yeah, so this is the OTEC facility over in Kona. So, like I mentioned, the Natural Energy Lab in Kona,
that? Yeah.
when you fly into Kona Airport, you can see it there. It's that point of land, Keohole Point, that's right near
And
the
that's
airport.
sitting right on the point?
And that's the tallest thing around down there. And it's the world's largest OTEC plant right now. So,
I kind of imagined it out in the ocean, but it's
Right.
actually
yeah, and so like
On
I
land.
mentioned earlier, offshore is eventually where
I
OTEC is
see, I
going to
see.
go. And the reason for that is you've got to get to really deep, really cold water.
I see.
And so
To
if
get the
you're,
differential.
yeah, and so if you've got a platform
Huh.
out at sea that's got a vertical pipe, that's a shorter distance than if you have to go kind of
along.
diagonally, if you will, along the seabed.
Huh.
And then also the wave loading of trying
on
to
the
anchor a
equipment.
large pipe down on the shoreline is a challenge. And so that is actually the first net power producing OTEC plant back in 1979.
Wow.
It was
That's
before my
kinda
time. Dating myself, but our
In a good
founder,
way.
our founder Joe Van Ryzen was involved and built the vertical pipeline that was designed, the pipeline that was on that structure, and that was kind of the world's first. It won a bunch
Wow.
of international and national engineering awards.
And was that off Kona?
And that was off Kona. And so that was
cool.
kind of the first OTEC project that Makai got involved in. And since then, it's been just kind of a number of marine pipelines, seawater air conditioning, and OTEC projects. I've kind of stemmed from that little project. And so that was, it was a really cool little demonstration plant.
That's neat. That's really neat.
And the unique thing about that one is that it generated more power than it took to power the pumps. And that was the first time that
So
had
it
ever
was
been done.
is actually generating
Yeah.
energy.
And so net power, so it had surplus power,
Huh.
which was a big deal. at that
Yeah.
time.
So it's more a proof of concept, like it could actually work.
Right, yeah. So OTEC, like I said, has been kind of demonstrated on a small scale
I
in
see.
different places, but it's never had a commercial scale plant.
So
that's
just
the next.
business feasibility, you need to be at a certain scale for it to make sense.
Correct.
I see. So it sounds like you guys do a lot of research, and I just mentioned SBIR companies. Have you guys done SBIR?
Oh yeah, and I was about to mention when you gave that last ad there. Thanks, by the way, to HTDC. We recently had a sonobuoy SBIR, so that's a buoy that's in the ocean that listens for submarines. And so we had a phase 1 SBIR and had a matching grant from HTDC.
great.
And so that's a new program. A little further back in 2012, we submitted one for an underwater vehicle, the one that I talked about. And I don't think we have a picture here, but it's basically a big autonomous underwater vehicle that you can throw over the board of a ship, and it goes to the seafloor and
Wow.
can lay cables by itself.
By itself?
Autonomously. And
Wow.
so that's that came out of the SBIR program, and actually HTDC's matching
Interesting.
grant helped us kind of beat out our competitors and get over the hump.
Wow.
And so we're really, pro
That's
matching
great.
program and the SBIR program in general. It's allowed us to spin off these technologies. So the OTEC program, that power plant that you saw there, has brought about $20 million in R&D funds into the state of Hawaii. And that
Wow.
started from a phase 1 SBIR.
That is amazing. So it's gone all the way to.
It gone all the way
Phase
to phase 3, and now
Huh.
it's just a Navy direct contract.
Wow, that's great.
And so that's really successful, but even that 20 million for the OTEC program, that's not as much as the cable software is even more successful because that's been longer, back in 2000.
Wow, did that
had
start
a-
off as an SBIR?
SBIR phase
Oh, yeah?
1. And so we had a little, it was, I believe, Cirrus and SBIR phase 1.
Yeah.
Remember when Cirrus was
Yeah.
around? We got a grant from them and a matching grant from HTDC again for phase 1. That kind of snowballed into
Wow,
a
that's
commercial
great.
software product that's been,
It's been selling.
about 30 million over the life of the system. So
Hmm.
it's a really, a tech export basically. We actually won the Tech Exporter of the Year for Hawaii
Wow,
for the cable software in 2003.
well, that's great.
And again, it was just came from this SBIR program. So
That's awesome. That's great news. Did you hear that, everybody? SBIR programs.
that's
Ooh,
right.
And we have another image. What is
Yeah,
this?
and so this is kind of the future of OTEC. So
this is the
you saw the
platform, yeah.
existing plant that's on land. This is the one that's offshore. So
Oh,
it looks a little bit like an oil platform, but instead of oil, we're just pumping seawater. And so you see the pipe, you can kind of see
Going
going
down.
vertically below the plant.
Uh-huh.
That's the cold water pipe.
Mm-hmm.
And then you'd be bringing warm water just in from the sides of the plant. And those big things on the side are heat exchangers. So those
Okay.
are what we use to extract the heat from the seawater.
Okay. I think
Generate
we have
power.
more pictures. Do we have any more pictures?
Slideshow. Okay, so this is a big cold water pipe. And this one's
Wow.
floating on the surface right now, but only because we're towing it into place and we're going to sink it. So this is it's a 55-inch pipe.
Oh my gosh, that thing
So-
is massive.
Yeah, so it's really, really quite a big pipe. And that's the one that goes to Natural Energy Lab at Kona.
Oh.
That supplies the cold water
For that
um,
plant that we saw.
Yeah, our OTEC plant doesn't actually use that pipe, but all the other tenants at the facility
Oh, I
do.
see.
And there's plans for another OTEC plant to actually use the water from that pipe as well.
Wow.
And so that is kind of the key for OTEC, is the big
The pipeline.
cold water pipe, because you need a lot of water.
Huh.
And so handling that big pipe at
Yeah.
sea is a specialty that Makai has
crazy.
kind of developed. And that's turned into other pipeline projects for fresh water, for wastewater outfalls, for oil and gas as well.
Yeah, I would think that helps. So just learning from that one project, you can apply it to a lot of different industries?
Yeah, exactly. And that was the largest and deepest seawater intake in the world. And again, won a bunch of
Wow.
international awards.
Holy cow. When was that?
That was-
When was that done?
Finished construction in 2001, and it's been operating there ever since. And so that's the lifeblood of NOHA, is that deep seawater. We've got, Big Island Abalone and all the other kind of companies there who use the deep seawater for research and
Oh, interesting.
commercial purposes, so
Wow, so you guys do
pharmaceuticals
so
and-
many different things.
stuff like that.
Are you guys hiring? Just to let everybody know, 'cause they're looking for
For
work.
if you're good. No, but we are actually we're seeking one numerical modeler, and so it's a pretty
Ooh,
specific
yeah.
skill set. You can look on
Yeah.
our website, but kind of a physics and engineering
Ah.
background, but with software engineering skills.
Huh.
So, yeah, we
That
we
is
were
pretty
pretty
specific.
selective, and we just hired kind of one or two at a time. But
Mhm.
right now we are looking.
Okay, great.
And we've got a couple big projects that if they go, we're a small
You'll be
company, so if
hiring.
we get one big contract, we gotta hire a couple. And it is tough, and I'm sure all the other tech companies in Hawaii know this very well. It's tough to find,
It is.
local talent who wants to stay.
It
Because we've had a
is.
bunch of really talented engineers from the mainland who come for a couple years and enjoy it, but then once it comes time to maybe start having kids
Huh.
or they just want to be closer to family, and then they move back to the mainland. So it's tough. And then, just the brain drain of our local talent as well
Yeah.
is tough.
And I
So
think it's tough if you're from the mainland and you don't know what it takes to live in Hawaii.
Yeah.
It's tough.
it's you need culture, and the cost of living is
Cost
so
of
high.
living. Yeah,
So-
exactly.
Yeah.
We're going to take a quick break.
Sure.
We will be right back. This is High Growth with HTDC, and our guest today is Duke Hartman, Vice President of Business Development at Makai Ocean Engineering, and we're on ThinkTech Hawaii, and we'll be right back. Thanks.
Hi, I'm your host on ThinkTech Asia, Bill Sharp. I look forward to you joining us each Monday between 4 and 5 o'clock when we film right here in our studio in downtown Honolulu. The show, ThinkTech Asia, focuses on contemporary events in Asia. And by Asia, we mean anything from Hawaii, south to Australia and New Zealand, west to Pakistan, and as far north as the Russian Far East. Clearly, this is one of the most economically dynamic centers of the world, and we bring you up to date on what's going on in a whole host of countries in this very vital region. We look forward to seeing you. Aloha.
Aloha, my name is Paul Jackson, better known as PJ, and my local interest is in sports. I have my own sports radio show at KWAI AM 1080 that you can stream live. I also have my own website, pjsportsradio.com. We have live guests in studio, and we talk about discussions and topics that everyone wants to know locally here on the islands. We cover everything from surfing to basketball to whatever's going on locally, sports-wise. We try to do our best and cover the topics in depth as much as we can. Once again, thank you for joining PJ here on Hawaii Sports Update. Mahalo.
Hi, welcome back to High Growth. This is HTDC. I'm your host, Cindy Matsuki. And our guest today is Duke Hartman, VP of Business Development at Makai Ocean Engineering. And they do some super cool stuff, like stuff that I didn't know was happening here in Hawaii, which is amazing. So we have a short video that we want to show that kind of talks about their submarine cable laying technology. And that's one of the newer and more profitable sides of your business.
Correct,
Is
yeah.
that
It's
right?
been around since about the year 2000 and helps folks install telecom cables so that run phone lines and the internet.
Like between islands or?
Between islands, between continents even.
Wow.
They string them from Japan to the
And Makai
West
does
Coast. No, we don't actually install them. We develop the software to help the
I
guys
see,
who
I
install
see.
them.
Well, that's even better.
Yeah, so I mean, sometimes our engineers do go on the vessel and help them install, but we don't own the vessels and we don't own the cable, basically.
Oh, interesting.
But yeah, it's been a really profitable. So this shows the three areas, so telecom, oil and gas, and power. Those are the three kind of types of cables that Makai Lake can help them solve. And so this first one, like I said, the
This
world
is the
looks kind of like a spaghetti
spaghetti.
bowl and this isn't even a half of them. There's more than that of telecom cables around the world.
Wow.
So it's how the internet, it's the explosion of the internet is made possible by these submarine cables.
Wow.
So you see there's a lot going between New York and Europe.
That's amazing.
But Makai basically developed a software to help install cables. Now we're seeing a lot more power cables, so subsea power cables. So that's basically a big extension cord that you lay on the floor of the ocean.
Wow.
And that's for offshore wind. You see there's some turbines.
Interesting. Yeah,
and then
yeah,
also
yeah,
just
yeah.
connecting island grids to other grids where you
Wow,
maybe
so
have
you
some
actually hardwired
excess
out.
power in one and excess demand in another. And then the third is, my head's blocking, but seismic oil exploration. So basically they lay these cables on the seafloor and then shoot an air gun, which
Through the
makes
cable?
sound bounce off the oil reservoirs that are below the sea surface, the seabed surface, and bounces back, and they can get a
and
picture of
of it.
what the oil is like under there. And so those are the three areas, so telecom,
Interesting.
power, and
Oil and gas.
oil and gas. And so, I mean, the software itself is a physical finite element model, if you want to get technical, but it takes into account all the physics that are happening with the cable. So
Like with the currents
the
and-
currents, the weight, the hydrodynamic drag of the cable.
As
and
it's
then,
being laid.
As it's being laid, and then it monitors the position and the bottom tension, and basically tells the cable ship operator, what do I do? If I want to hit this little path on the seafloor, how do I navigate? And so you can actually allow the software to take over and drive the
that's
ship if you
amazing.
like. so that you don't over-tension the cable. So you don't want to lay the cable too tight, and you also don't want to lay it too slack, because you don't want to have kinks and loops. You've seen an extension cord, when you get it all tangled up, it's a mess. So you want to have the right amount of tension, and you also want to hit your target in terms of the bottom placement on the seafloor.
Wow.
So
So
the
when it
software-
has loops and stuff, does that affect the transmission of telecom, or?
It could. If it's not damaging the cable, it won't. But
I see.
if you get a kink and then
see.
it
And
gets,
it gets pulled.
taut, you can actually damage the fiber optic, the fibers. And especially with power cable, that's much more sensitive, and it's a thicker cable. And so if you kink that, you're in trouble.
And I would imagine that's almost impossible to fix, or extremely
you just
expensive.
have to get a grappling hook basically and pull that cable up.
Oh my gosh.
And go back to where it was damaged, cut it on either side, and splice
it together.
basically.
Holy
And so
cow.
that's
And then
as you
relay
can
the
imagine,
whole thing out.
really expensive operation.
Wow.
These vessels can be, $50,000 a day plus, just
Wow.
and much more than that in some cases.
That's amazing.
To do the at-sea operation. So if you save just a day or
Yeah.
two, you've paid for the software.
That's amazing. I could see why that's in demand.
Yeah.
So it's just a software.
It's a software, and we do
That's
provide
great.
services in terms of route engineering. So if someone comes with us, to us
Like,
with a
what's the
cable
best route?
project, what's the best route? What are things we should worry about? And then at sea, they sometimes want an engineer to help the operator navigate and make sure they know how to use the software and install it properly.
Ooh, that sounds kind of fun.
And so there's, you might have heard of the inter-island cable between Maui and Oahu. Makai thinks that's a great idea. It would increase the stability of our grid and allow, Maui's got a lot of wind power, we've got a lot of demand. So from a technical standpoint, it looks like a no-brainer.
It's possible.
It looks like a really good project.
Very exciting. That's so great.
Yeah.
I'm impressed. I'm impressed with all the tech and innovation that's going on at Makai Ocean Engineering. Thanks so much for being here today.
Thank you, Cindy.
My guest today is Duke Hartman, Vice President of Business Development at Makai Ocean Engineering, and they're out at Makapu.
Yeah, the pier. We had a picture of the pier. Do you guys have that? That's kind of our biggest promotional. There it is. Biggest promotional thing is that's where we work. You want to work for Makai?
That's sweet. I'm gonna have to do an office visit.
Yeah. So we get to take, before and after work surf breaks and that kind of thing.
Nice. Did you hear that? Numerical, whatever person they're looking for.
Yeah, that's right. No, we developed a video recently where we had a quadcopter go around and take
The
a
office.
video footage of it, and that's going to be our kind of promo video for hiring people. So hopefully
that's
that'll
nice.
attract some
I
folks.
bet. Thank you for being
Thanks,
here. That
Cindy.
looks like really fun. And thank you, everybody, for watching. This is High Growth with HTDC on ThinkTech Hawaii, and we'll see you next time. Thanks.